As the expanding dome reached critical thickness, the ice sheet fractured along a line stretching several kilometers. Satellite footage documented the slow widening of this fissure as plumes of vapor and particulate matter erupted from its depths. The release produced a thunderous resonance picked up by audio sensors placed across the polar region. Analytical teams identified harmonics within the sound waves consistent with massive mechanical displacement. The signal suggested that the force behind the event had reached the threshold necessary to breach the final layers of ice. Infrared imagery captured a central hotspot intensifying rapidly. Temperature readings soared far above what even the most energetic geothermal systems could produce in that environment. The phenomenon displayed a distinct core of concentrated warmth surrounded by pulsating rings that expanded outward and cooled gradually. These rings indicated cycles of internal energy discharge that resembled physiological processes on an unimaginable scale. Biogeochemical samples obtained from the expanding fissure contained molecular structures unseen in any known lineage. Proteins displayed folding patterns resistant to extremes of heat, pressure, and cold. Cell-like vesicles exhibited membranes built from compounds absent from contemporary biospheres. Some vesicles showed signs of active reorganization under microscope imaging. Researchers debated whether these fragments represented shed components of a colossal organism or ancillary systems disrupted by its ascent. Surface deformation accelerated. Large sections of ice collapsed into the widening fissure, revealing a cavernous void filled with dense mist. Instruments detected moving mass far below, though optical technology could not penetrate the obscuring vapor. Seismic readings indicated powerful upward surges consistent with coordinated structural motion. The mass did not rush impulsively, but rose in deliberate phases as if following an innate biological cycle. Global scientists issued emergency advisories. Not only did the phenomenon threaten the structural integrity of the ice sheet, but its emergence could release ancient compounds into the atmosphere and ocean with unknown ecological consequences. Environmental models forecast potential disruptions to ocean currents and atmospheric chemistry should the event continue without mitigation. The scientific fields of climatology, geology, and biology converged in unprecedented collaboration to analyze the unknown entity. As the fissure widened further, the cavern emitted low-frequency vibrations powerful enough to generate traveling waves across the ice surface. These waves propagated outward and caused microfractures thousands of meters away. Analysis linked the waves to internal contractions of the rising mass. Such energy suggested musculature or equivalent mechanical structures of extraordinary strength. The mass exerted force comparable to tectonic pressure, yet displayed rhythmic patterns that distinguished it from geological shifts. New spectrographic results revealed the release of metallic compounds associated with deep-sea mineralization. Their presence indicated ancient geological layers torn upward by the ascending structure. The mixture of organic matter and mineral residues created a complex plume that drifted into the upper atmosphere. Satellites recorded changes in light scattering patterns as the plume interacted with polar winds. The glowing aura captured in images raised public curiosity when partial data inevitably leaked. International agencies officially acknowledged that a massive biologically associated structure had awakened beneath polar ice. While the exact nature of the entity remained unknown, all evidence pointed to the emergence of a living system of remarkable complexity. It had rested for unimaginable spans of time, preserving metabolic potential until unknown triggers initiated revival. The absence of historical precedents meant the scientific community had no established framework to guide interpretation. The fissure finally revealed glimpses of movement through shifting layers of vapor. Monitors captured oscillations of density within the mist consistent with large-scale contractions or undulations. Although no direct image displayed the creature or structure itself, the environmental reactions confirmed its presence. The world watched as the anomaly drew closer to the surface, bringing with it atmospheric distortions, geological tremors, and biochemical emissions. With each passing hour, scientists realized that the phenomenon represented not merely a biological curiosity, but a planetary-scale event. The awakening of the massive entity beneath the ancient ice signaled the start of a new chapter in the study of Earth's deep history. The panic that spread among global research institutions arose not from fear of the unknown alone, but from recognition that the world had encountered a form of life unlike any previously imagined. The monster beneath the ice had awakened. Its emergence reshaped scientific understanding and forced humanity to confront the profound mysteries still hidden in the most remote corners of the planet. Human scientific attention had long been drawn to the polar regions where ancient ice preserved the memory of vanished climates and forgotten epochs. Year after year, expeditions returned with meticulously gathered cores that revealed trapped air from distant ages, along with geological and biological matter sealed away in deep frost. Long-standing models treated these ancient deposits as stable reservoirs that changed only under predictable thermodynamic processes. The assumption that nothing within them could stir on its own had persisted without serious challenge. This sense of certainty changed when a sequence of unusual thermal readings appeared in data collected from an automated drilling platform placed far out on the continental ice shelf. The sensors built to measure micro-fluctuations in temperature began to transmit inconsistent profiles that did not match the expected distribution. At first, the anomalies seemed to be machine faults that might result from pressure distortions caused by shifting snow mass, yet diagnostic routines confirmed that the instruments were functioning correctly. The unusual warmth radiated from regions that should have remained locked in deep freeze. Remote imaging followed. Ground-penetrating scans suggested the existence of a cavity many meters below the platform. It was not the presence of the cavity itself that raised concern, since voids sometimes formed when older ice compacted unevenly. The alarming detail lay in the energy signature within that hidden pocket. It displayed a slow, rhythmic pattern reminiscent of organic thermogenesis rather than geological activity. Scientific teams back at the interpretation centers found themselves reviewing previously dismissed data from older missions. Twice in the past decade, irregular pulses had been recorded in nearby locations. Both instances had been archived as noise interference produced by drifting magnetic storms. Now the old assumptions seemed suspect. If those earlier pulses resembled the newly found thermal rhythm, they might have hinted at a long-concealed phenomenon. Environmental modeling systems were then tasked with simulating possible explanations. The models could not replicate the oscillations with any process involving standard cryogenic mechanics. The only matches came from simulations of metabolic activity in larger-scale organisms subjected to extreme cold. Yet no organism of substantial mass was known to survive beneath polar ice for extended geological periods. Microbial colonies, perhaps, but nothing beyond the microscopic. The suggestion that something larger might rest or move below the surface defied the catalog of life known to science. As the scans continued, the cavity seemed to change shape. Its perimeter widened by small but measurable increments, as though something within shifted position or exerted slow pressure against the surrounding frozen walls. The discovery drew immediate scientific focus because the force required to reshape ice at those temperatures exceeded the potential of mere thermal expansion. It hinted at active mechanical influence within the void. Ecological records added another dimension to the mystery. Surrounding zones showed subtle variations in surface chemistry. Traces of compounds usually associated with ancient marine sediments appeared unexpectedly near the drilling platform. Those compounds had no business existing on the surface of a region that had been sealed for tens of millennia. The only plausible pathway required upward movement from deeper strata. The first cautious theory proposed the awakening of a dormant biological mass preserved within ice since prehistoric times. If such an organism existed, its revival would constitute a momentous event offering insight into life resilience under extreme conditions. Yet early enthusiasm gave way to sobriety, as further data portrayed growth patterns too rapid and energetic for a creature emerging slowly from dormancy. The phenomenon behaved less like reanimation and more like emergence of something that had never fully ceased activity. Global research institutions increased monitoring frequency. Satellite-based sensors observed faint vibrations across the region. These vibrations fell outside the usual range of tectonic quakes and instead resembled low-frequency pulses distributed over wide areas. The idea that something beneath the ancient ice might be stirring began to take shape as a deeply unsettling possibility. By the end of the initial observation period, the scientific community realized that the event could not be dismissed as mechanical noise or transient natural shifts. Something beneath the ice had begun to wake, and its presence challenged all known frameworks of cryobiology and geophysics. The world awaited further information with quiet apprehension. As the anomaly expanded, researchers redirected orbital platforms to provide continuous radar and infrared observation of the affected zone. Day after day, the signals grew stronger. The cavity that had once appeared as a singular pocket now exhibited branching structures extending outward like channels formed by unseen flows. These extensions advanced through solid ice in a manner that defied common glaciological processes. Thermal imaging displayed gradients that shifted too rapidly to be driven by seasonal variation. Something was moving. In controlled analysis rooms, scientists compared the readings to known biological energy signatures. They could not escape the conclusion that the pulse patterns resembled circulatory rhythms of large organisms measured in laboratory studies. However, the scale dwarfed anything within the current classification of life. The frequency and amplitude suggested a vast mass engaged in periodic contraction and expansion. No natural geological event produced such an organized pattern. Seismic sensors distributed across the polar region recorded faint tremors that did not radiate from tectonic boundaries. Instead, they emanated from the interior of the ice sheet near the expanding cavity. These tremors displayed an uncanny regularity, almost as if produced by intentional movement. Though the notion of intention belonged to speculative thought rather than empirical science, instruments provided no alternative explanation. The magnitude of the pulses grew slowly but steadily. Chemical analysis of nearby snow layers revealed increased concentrations of ancient organic residues. Some samples contained proteins that matched long-extinct marine fauna from epochs predating human existence. These molecules would normally degrade after extended exposure, even in frozen environments. Their presence in fresh layers implied recent displacement from deeper levels and possible disturbance of buried organic matter by emerging forces. Oceanographic satellites detected subtle changes in sea ice drift patterns near the continental shelf. Currents that remained stable for centuries began to deviate as if influenced by slight gravitational disturbances. The shifts were small but statistically significant. Hydrodynamic models incorporated the data and produced scenarios that attributed the changes to redistribution of mass deep beneath the ice sheet. If a massive entity relocated position, the gravitational field would adjust accordingly. This once theoretical possibility now appeared plausible. Additional paleobiological studies considered whether the event might involve a unique form of ancient extremophile life. Fossil records hinted at giant organisms that once navigated prehistoric oceans long before polar regions froze. While speculative, the concept of a survivor species sealed beneath accumulating ice layers gained traction. A creature adapted to extreme cold and capable of metabolic suspension could theoretically endure until conditions permitted renewed activity. Yet even the most speculative reconstructions did not match the size indicated by seismic data. Collaborative task forces then examined whether the observed signals could stem from geothermal dynamics. Volcanic chambers sometimes produced rhythmic vibrations. However, geologic maps of the area showed stable rock layers without volcanic activity for millions of years. Temperature readings also displayed organized patterns inconsistent with geothermal convection. The coordination in timing and spacing of the pulses required a mechanistic process, more systematic than molten rock movement. As days progressed, the cavity transformed from a relatively spherical void into a sprawling labyrinth of interconnected passages. Ice layers near the surface began to fracture with increasing frequency. The fractures formed parallel lines extending outward from the central anomaly. Satellite spectrometry revealed that the fractures emitted faint plumes of vapor not normally associated with cryogenic cracks. Within the vapor appeared microscopic particles of organic matter that matched no known living or fossilized species. International climate institutes issued cautious bulletins acknowledging the unprecedented nature of the event. They advised that traditional interpretations of subglacial stability might require revision. Although the public had not yet been fully informed, rumors spread among scientific communities, describing the possibility of a colossal biological structure stirring under the ice. Despite the absence of designated characters or narrative individuals, the collective voice of research organizations communicated rising alarm. Data streams continued without pause. The pulse patterns increased in intensity, ice fractures multiplied, and chemical signals grew more complex. A singular conclusion began to take form in analytic reports. Something of enormous scale was ascending from the ancient depths, modifying its environment as it rose. The scientific world braced for developments that might rewrite the fundamental understanding of life on Earth and force reconsideration of long-held assumptions about the limits of biological endurance. Weeks after initial discovery, the surface above the anomaly experienced notable deformation. Satellite altimeters measured progressive elevation changes as the ice sheet bulged upward in a dome shape. The rate of growth accelerated beyond anything consistent with subglacial water movement. Acoustic sensors embedded in the ice detected a deep resonant vibration traveling outward in concentric waves. Instrumental analysis likened the pattern to the motion of immense structures pushing against resistant material. Field sensors placed kilometers away began reporting unexpected temperature rises. Although minor in absolute value, these increases occurred at locations that should remain insulated by thick ice. The warming effect emanated from below rather than above. Energy models suggested an internal heat source capable of radiating through many meters of solid ice with surprising efficiency. This heat did not dissipate in random fashion. It traveled along specific trajectories carved within the glacier by the advancing phenomenon. Microscopic study of airborne particles released from new surface cracks yielded further astonishment. The particles were not inert sediment but complex biological remnants containing proteins previously unknown to science. Their molecular architecture implied adaptability to immense pressure and intense cold, combined with periodic metabolic bursts. Researchers could not determine whether these particles originated from the primary mass or from disrupted surrounding organisms once buried in ancient seas. Regardless of origin, their presence indicated active transport from deeper layers into the open atmosphere. Remote seismic sensing platforms noticed that the rhythmic pulses had changed character. They became more frequent and exhibited higher harmonics, suggesting increased movement within the emerging structure. Some analytic models proposed that the entity was attempting to navigate through progressively thinner ice layers toward the surface. These interpretations remain speculative yet aligned with observable data. Every tremor corresponded with new cracks, each crack followed by additional release of ancient organic compounds. Weather satellites reported anomalies in local atmospheric pressure. Regions above the rising mass exhibited recurring pressure drops unrelated to prevailing meteorological systems. Atmospheric scientists surmised that escaping gases from beneath the ice contributed to the localized fluctuations. These gases contain traces of long-trapped atmospheres capable of affecting pressure gradients in subtle but measurable ways. Their release corroborated the widening fractures and upward displacement of ice. Oceanic monitoring networks detected disturbances in deep sea pressure along the continental margin. The sensors implied that mass was shifting beneath the connecting strata between land-based ice and marine sediments. The movement created gentle but persistent oscillations in surrounding water columns. No known geological process in that region could account for the simultaneous changes across ice, land, and sea. The event had become a truly multidisciplinary enigma, drawing interest from every branch of the natural sciences. Geochemical probes inserted into meltwater produced astonishing readings. Concentrations of heavy isotopes rose sharply compared with baseline values. The isotopic signatures matched elements often found in the remains of archaic deep-sea organisms. These elements likely originated from layers that had been untouched since the formation of the ice sheet. Their sudden appearance demonstrated powerful upheaval forces pushing ancient material toward the surface. The bulging dome grew each day, reaching sizes that redefined expectations of subglacial mechanics. Crustal stress maps revealed zones of high tension radiating outward from the center. Computer simulations struggled to produce any natural configuration that could replicate the observed changes. The models required insertion of a massive internally active body exerting continuous pressure on surrounding ice. Public agencies released controlled statements acknowledging unusual ice dynamics, but withheld deeper interpretations until analysis reached greater certainty. Nonetheless, observers soon noticed plumes of vapor rising from the expanding fissures visible even from orbit. These plumes intensified in volume and occasionally carried faint luminescence, possibly caused by chemiluminescent reactions within expelled organic matter. Such behavior suggested dynamic biochemical activity beneath the surface. A profound sense of anticipation filled scientific platforms. The surface had begun to yield. Whatever had stirred within the ancient ice was approaching the world above. Each piece of evidence pointed toward imminent emergence. The global scientific community faced an unprecedented moment in the study of life and geological transformation as they awaited the next stage in the unfolding phenomenon. We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next. Your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.